Welcome. In this video, we're going to do another integral using the substitution technique. We have the definite integral from 0 to pi over 4 of tangent squared theta divided by cosine squared theta d theta. For this one, we need to quickly remember something from trigonometry or maybe pre-calculus if that's what you learn this material. We need to remember that secant theta equals 1 over cosine theta. And actually, I'm going to rewrite this just the other way. In other words, 1 over cosine theta equals secant theta. So 1 over cosine squared theta equals secant squared theta. Wonderful. Let's rewrite this as the integral from 0 to pi over 4 of tangent squared theta, secant squared theta, d theta. And now let's see if we can identify a function in a function whose derivative is multiplied to the function composition. That is, I want to find some function of theta, f composed with g of theta, so that as you see here, the derivative of the inner function is multiplied to the outside. And I see that here. So I'm going to rewrite this one more time to see if you can see what I'm seeing before I say it. Do you see the function composition? Our outer function is squared, so just something squared. The inner function is right here as tangent of theta. And in fact, the derivative of tangent of theta is secant squared theta. So I'm going to let W equal tangent theta, then dW equals secant squared theta d theta. And if you notice, right here we have dW. So let's rewrite this as the integral, and I'll get back to the limits of integration after we rewrite the integrand of w squared dW. So now let's discuss the limits of integration. Let's start with the lower bound of 0. When theta equals 0, w equals tangent evaluated at 0, which is just 0. For the upper bound, when theta equals pi over 4, w equals tangent evaluated at pi over 4, which is just 1. So my upper bound is 1, my lower bound is 0. So this becomes w cubed over 3, evaluated from 0 to 1. And that is just 1/3. And I think I might be running out of space, so let me move that here. 1/3. So let's check our work. And in this case, to check our work, I'm going to actually use the indefinite integral. I'm going to start here with w cubed over 3. And down here at the bottom, the integral of tangent squared theta over cosine squared theta d theta is equal with the substitution w cubed over 3. But now we want to back substitute since w actually equals tangent of theta. So this is tangent cubed theta over 3. Wonderful. Let's take the derivative of this one. So we're going to find the derivative of this one in our check. So the derivative with respect to theta of tangent cubed theta over 3. And my first step, I'm going to rewrite this as 1/3 times the derivative with respect to theta of tangent theta, the entire quantity cubed. And that'll make it really clear that we're using the chain rule here. So this is 1/3 times 3 times tangent theta and this whole quantity squared. Then we apply the chain rule and take the derivative of tangent, which is secant squared, and multiply it. Simplifying, we end up with tangent squared theta, secant squared theta, and then using trigonometry, we can rewrite this as tangent squared theta over cosine squared theta. This here matches our integrand here. So we are done. We can rest assured that our answer is correct.